Okay, so you were given an opportunity to take a look at these different graphs, and based on the question, to go ahead and answer with your partner. And then you were given an opportunity to go to different types of waves and answer those as well. I'm going to go ahead and answer these for you, and I'll post them on hopefully tonight if you still have any questions. Again, the first question said, precisely measure the amplitude and wavelength of the wave below and label them with arrows. So if I look at the very first one, where is my wavelength on this graph? So we can measure it from this point to this point, or this point to this point, or, and I'm going to go for red, from this to this, okay? Either way, if I go ahead and use my ruler, and again in centimeters, this was about 3.5, right? 3.5 centimeters.
Yeah. No, on centimeters. Remember.
Okay? Right? Okay. Now, what about the amplitude? Where's the amplitude? So it could be from here to here, or here to here, or any of the other ones that you have. So again, using my ruler to measure, we have 1.5 centimeters. Centimeters. Okay? What about the number of wavelengths? You have 1, you have 2, and 3. Okay? So from beginning to the end of the wave, and that is 3 wavelengths. Any questions so far? All right, let's go ahead and do the second one. Some of you had number 2, and you had to measure. It says on the graph below, draw another wave which has the same wavelength but half the amplitude. So, same wavelength tells me how many wavelengths am I supposed to have?
3.
Same wavelength. So a total of 3. Half the amplitude, what am I supposed to do? So you measure the amplitude exactly, and down the middle, Zahra said, is where your highest point would hit. Okay? So I have the same wavelength. I know that each of these is supposed to hit the middle here. Okay? I think I was a little bit off there. But it's the same wavelength. So my wave will go up, down, up, down. Approximately. I mean, I'm not 100%. Okay? Any questions so far? Okay. The last question that some of you had to answer, it says on the graph below, draw a wave which has the same amplitude but twice the frequency. So what do I do here?
Guys, if you're talking, you're not making a good choice.
Awesome. Thank you, Jehan. So she said we have to have a total of 6 waves because we have twice the frequency. Okay? But what can you tell me about the amplitude? It's going to be the same. So it's going to hit the same highest point. So what I'm expecting to do, the middle of my wave is going to hit around here for every one of these waves. Okay? So I start at the same point, hit the same highest point, down and up, same lowest point. So mine, it's a little bit right there. Okay? Again. And then we're doing the same thing. So we're going to have how many waves? Up, down, Okay, again, up, down. A total of 6 waves. This is an approximation. Sorry for the messy drawings, but approximation of what it's supposed to look like. Any questions? Okay, so this is for this one. The next, or on the back of each of your parts, you had questions where you were supposed to use the formulas that we've learned to answer them. So I'm going to pause and pull up the other one. So in here, this question we said a little kid waves his hand back and forth 25 times in 10 seconds. Okay? What are the frequency and the period of this oscillation? So again, we know that the frequency, okay, is equals to cycles per 1 second. But here, since it's in 10 seconds, we got to figure out the frequency first, which is 25 divided by 10, which is equal to 2.5. Frequency, that is hertz. So that's your frequency. What is the period? T is equal to, I'm sorry? No, because we're trying to figure out the frequency based on what we have. So the T is equal to 1 over F, which is 1 over 2.5, which is equal to 0.4, I believe. And then that is seconds. And this one, basically, this question allows you to use another formula that we've learned. Ali? So it says the average teenager can hear frequencies that range between 20 and 20,000 hertz. If the speed of sound in air is 340 meters per second, what are the shortest as well as the longest wavelengths? So, Ali, can you give me the formula for speed? What's the formula for speed, Zahra? Exactly. Okay. What are we looking for here, Ali? What is the question asking us for? The wavelength. Which one is the wavelength, Ali? Okay, so the wavelength is equal to the V over the frequency. Okay, so we have two frequencies that we're looking at, but we have the same velocity, but we are being asked for the shortest and the longest. So for the shortest, we use 20, and for the longest, we use 20,000. So 340 meters per second divided by 20 will give us the shortest, which is 17. What is the unit? What is the wavelength? So what is my unit? Frequency is hertz. It's meters. Awesome. Okay. Frequency is hertz. Speed is meters per second. And your wavelength, we said it's a distance. Remember when we talked about that? So I'm going to go ahead and make sure you got this correctly. It's meters. Okay. Now, for the second one, for the longest one, we're going to use velocity of 340 again, divided by the longest wavelength, which is 20,000, which is equal to 0.0. Is it 0.17? Okay, meters. Any questions? Okay, so the next question that some of you had is asking us, a string vibrates at a frequency of 20 hertz. What is the period?
1 over 20 equals
Awesome. So 20 hertz is my frequency. I need the period, which is t. So t is equal to 1 over f, which is equal to 1 over 20, which is equal to 0.05. What is the unit? Seconds. Period is in seconds. It's a time. And then the last one, this one nobody had, so but it gives you an opportunity to practice a little bit more. It says a swing has a period of 10 seconds. What is the frequency? Which formula are we using? Awesome. F is equal to 1 over t, which is 1 over 10, which is, what's 1 over 10? 0 point. You're just moving the decimal once. 0.1. Okay? And what is the unit for frequency? Hertz. Any questions?